Hello, geometry class. Today I'm going to talk about chapter 7, section 5, the tangent ratio. So we're going to talk about trigonometry now. And trigonometry is a huge, broad field, and half of pre-calc will be trigonometry. So this is a little preview into much more complicated stuff that'll come in a couple of years. But let's just recap what a ratio is for a second. A ratio is a comparison of two numbers. When you first learned ratios, you probably learned them like this. A colon B. That is a ratio, but if you remember, you can write that as a fraction. It's possible to write a ratio as a fraction. So we're going to be writing the ratio as a fraction, but it's a comparison of two numbers, a number over another number. And I'm going to delete that and switch back to my panning hand. Okay, so the tangent is a ratio, the ratio of the lengths of the legs of a right triangle. So tangent is a comparison of two legs of a right triangle, and it will be the tangent of a certain angle will be the comparison of the two legs of a right triangle. Okay, so it's always tangent of an angle. Tangent of an angle is equal to the ratio of the legs. So, for example, here visually we can look at this ABC triangle. So we always have to ask ourselves, what angle are we looking at? Or what angle is our focus? And if the angle focus is A, okay, so tangent of A, then there are two legs, and we need to identify or separate those two legs. You'll have an opposite leg because this leg, of course this is a leg and this is a leg. This leg that's opposite A is the only leg or side of the triangle that's not touching A. So this is opposite. Adjacent will be the leg that is touching the angle A. So adjacent means next to, makes sense. Opposite is across from. Of course, we have the hypotenuse, which is the side of the triangle that's not a leg, but we're looking at the two legs here. So the tangent of angle A is equal to the opposite leg over the adjacent leg. Okay, opposite over adjacent. Opposite over adjacent. So that is the ratio. Whatever value opposite is and whatever value adjacent is the ratio we're talking about when we're talking about tangent. Okay, opposite over adjacent. Tangent of A is opposite over adjacent. Now what leg is opposite and what leg is adjacent changes if we're changing the angle focus. So this is only true for angle A. If we change it to B, then opposite will be this side and adjacent will be this side. Okay, so for tangent, it's very important to remember tangent is equal to opposite over adjacent. It's important to remember which sides are legs and understand that this is a ratio. Well, let's do an example. If this is kind of fuzzy, maybe doing an example with actual numbers will help. So example 1, find tangent of S. Tan S means tangent of S. So this TAN is a short way of writing tangent. This is technically tangent of S. This is technically tangent of R. Sometimes I might say tan S as shortening what this actually means, which is tangent of S. Okay, it's asking us to write the fraction and as a decimal. So tangent of S. So I'm looking at S here. Up here's S. When we're looking at S, the leg opposite of S is 80. Okay. The leg adjacent to S is 18. Hypotenuse isn't used at all. That 82 doesn't matter. We don't need that when we're trying to find tangent of S. tangent of angle S, whatever that angle measure is, and it is an angle measure of some sort, will be 80, over 18. You take your graphing calculator, which I need to boot up here. Sorry. And you take 80 over 18, simplifies to 40 over 9. You see that by dividing by 2, and you get 4.444. Tangent of S is equal to 4.444. Tangent of R, it's also asking for tangent of R. Tangent of R now, we're looking at this angle. We're changing our focus. Okay, now, since we're looking at tangent of R, the opposite side is now the 18. The adjacent side is now the 80. 18 and 80, okay? Opposite, adjacent, if we're looking at R. So it's very important that we know which angle is our focus, okay? Whichever angle is your focus changes everything. So opposite, 18 over 80, tangent of R. 18 over 80 simplifies to 9 over 40. Put it in your calculator, 9 divided by 40, and you'll see you get 0.225. And that's what they're asking for, okay? Why is this helpful? Well, you'll see in example 2 that sometimes when we're given a right triangle, we're given an angle, we're given a side, but we're missing another side. Tangent enables us to find the value of x in this scenario right here that I'm showing in example 2. We don't know this side length. We do know this, and we do know the angle. And now we're able to find this side length from these two pieces of information, an angle and a side. Okay? It's because tangent of 32, so here's our angle. Angle's here. Opposite of that is 11. Adjacent to that is our unknown x. So we can write tangent of 32 degrees is equal to 11 over x. Now, you might ask yourself, well, what do I know? How do I know what tangent of 32 degrees is? You will be given, or you will have access to, this table. This is a table of values. And you can see there's 3 columns here. We're interested in the TAN column for now. We'll get to the other 2 columns. But right now we're just interested in the TAN, tangent column. Okay, so this over here is angle, is the angle measures. This is a very important column for all of this page. All these 3 columns relate back to this angle column. So what I want to do is, if I'm looking for tangent of 32 degrees, I'm going to come in here and I'm going to go down the angle column. Okay. It's 22, then it goes up to this over here. Yeah, so it's continuing over here. I made this before I realized we would be doing this online. I was going to hand you a sheet, a 2-sided sheet with these 2 pages. So now 23, and I'm looking for 32. Tangent of 32, right here it is. Tangent of 32. Okay, or the angle measure 32. And I'm interested in tangent. 0.6249. So tangent of 32 is equal to this ratio, this decimal value ratio, 0.6249. They gave you 4 decimals here. Usually I'm interested in 3 in answers, so it gives you an extra decimal to spare, which is nice. So I can then, and I'm not going to do it right away, but anytime that I can at some point change tangent of 32 to that decimal value, 0.6249. And I'll do that in a minute. But before I do that, if I'm solving this for x, and I know that this tangent of 32 degrees is a number, so I'm going to treat that like a number. Treat it like 7, treat it like 17, treat it like pi, any other number. Solving this for x, I'm going to multiply both sides by x to start. And so I'm going to have x on this side, cancel out with the x down here, and then I'll have an x on this side. Okay? See how I move that x over? Then this is a number, so I can divide by tangent of 32 degrees. Okay? 11 divided by tangent of 32 degrees is what x is equal to. And at this point, I'm going to change tangent of 32 degrees to the decimal value 0.6249. Okay? Or, because I'm only interested in 3 decimal values, 0.625. I'm rounding up. Okay? I'm changing this to approximately. Here's an important thing. All these values are approximate with the exception of 0.5. Anywhere you see a 0.5 it terminates. That's actually an exact value. All these other values in here are actually rounded. Even though they're 4 decimal places, they would go on further than that. For 0.5, and also zeros and ones are also exact. So the 0, the 1, the 0, this 0.5, and there's a couple other 0.5s in here. There's another one. Every other value listed in here is an approximation. So when you're using this sheet, every time you look to this sheet, almost every time, 99% of the time, 98% of the time, or maybe a little less than that, but or a little, yeah, whatever. You're gonna want to change. You're gonna need to change your x from an exactly equal to an approximately equal to. So I have 11 divided by this decimal value, and yet I switched that to approximately equal to. And now I'm gonna go to my calculator and do this operation on my calculator. Make sure I have it right before I hit enter. I get 17.6. This is an approximation. 17.6 is sufficient. You don't need, did I say 3? Nope, I did not say 3 decimal places. I'm actually going to change this right now to just 1 decimal place. Typically for sides, 1 decimal place is enough. So unless I say otherwise in the problem. So 16.6, oh, wait, did I do something wrong? I think I wrote the answer wrong. Because I have 17.6. Alright, I'm going to double check this, and I'm going to do that by, so if I do tangent of 32 degrees, I get the tangent, mode. Oh, that might be my problem. No, that shouldn't be my problem. Tangent of 32 degrees is 0.6248. 6249, 6248, yeah, that would round out to 9. I'm just trying to figure out, I might have wrote the wrong thing down. And then I'm going to take 11 divided by 17.6 is what my calculator gave. Okay, yeah, that looks like, it's looking like I wrote the wrong thing down. Yeah, that should be 17. It's going to be hard for me to write a 7, but I'm going to try to do it with my cursor. Okay, 7 is actually one of the easier numbers to write. All right, so that should be 17.6. Oop, don't want the eraser, I want the hand. Okay. All right, so 17.6 should be the x value. Sorry about that mistake. So I got that by, once I converted tangent, just to recap, once I converted tangent to the decimal value, 3 decimal places, I give 4 on here, but when you're plugging the value in here, I want 3 decimal places, and then when you find the final answer, it's okay to do 1 decimal place, because you're not going to be reusing that final answer. If this problem was more involved and you were using that number again, then yes, you should probably keep 3 decimal places until you're at the end. You don't want to round and then reuse that number elsewhere, because you're already rounding, and then if you're multiplying by it or whatever, you're magnifying the rounding error even more. So 17.6. Example 3, we have another problem here, and this has a lamppost. We want to find the height of this lamppost. We have a right triangle. We have the base of 40 inches. We have the angle of 70, which is given. So this is our angle of focus here, this angle here. The h is the opposite. The 40 inches is the adjacent. Remember, tangent of 70 is equal, or tangent of an angle is equal to opposite over adjacent. Opposite over adjacent. So we set this up. Tangent of 70 will be equal to h over 40. So in order to solve this, again, we want to isolate h. Well, this one's a little nicer because we can just multiply both sides by 40. So the 40 can go up there, 40's cancel out on this side, and the 40 goes up there. So I'm just going to rearrange it, putting the h on the left. We like to have our unknowns on the left and our knowns on the right. Tangent of 70, going back to this. Now, let me unclick that. Tangent of 70. So I'm going to continue going down here. This side of the sheet goes to 45. Flip it over, or scroll, well, if it was printed out, you'd flip it over, but in this case, you're going to continue scrolling down all the way down. You can see 70 at the top, but I wanted to show you that you just keep following down, and then it comes up here, and 70 is here, and our value for 70, tangent of 70, is 2.74, and we're going to round that to 8. Oops, I rounded down. Because it's 5, it's pretty close to either side, but 2.747 should work as well. And so I'm on my graphing calculator, or on your calculator. You don't have a graphing calculator, that's fine. Do 40 times 2.747, and we get 109.88, and 109.9 will suffice in this case. So I'm going to, because one decimal place is fine for the answer, so 109.9 will suffice. Okay, round it up. Hopefully that makes sense. So it's actually, I'm going to answer that as it's almost 110 inches. And the unit was inches, so the answer should have inches. Okay, so those are 3 examples of tangent. I have some bookwork here again. I will take these screenshots and put them up for you to look at those problems. I have a work packet. I will put that in PDF form and post that as well. And so this is tangent. This is the tangent function. So thank you and good day.